So this is the algorithm that I used to code my synthetic division calculator. So what it does first is it gets both of these polynomials, which is the divisor and the dividend. And it stores these polynomials as their coefficients. So for this one, for the divisor, it'll be 1x squared plus 0x minus 1. These are the coefficients, so the array would be 1, 0, and negative 1. And for the dividend, it'll be 2, 3, negative 1, 7, negative 1. 2, 3, negative 1, 7, and negative 1. So what it does next is it gets the minuend. The minuend is what gets subtracted in a subtraction problem. So it does this by counting the number of terms in the divisor, which is 3, because you have x squared plus 0x minus 1, 3 terms. So the minuend would end here, because these are the first 3 terms of the dividend. So then it finds what I call A, which is this term right here, and it's basically just the quotient, the terms in the quotient. So it finds what you multiply the leading term of the divisor by, which is A. So this times A is 2x to the 4th. And you just solve for A, and A equals 2x to the 4th over x squared, which is x, or 2x squared. Now that A is found, we multiply A by each term in the divisor, and then that's how you get the subtrahend. So let's do that real quick. So this right here, this is our minuend, and this is our subtrahend. And then we just subtract these, so you get 0, 3x cubed, and x squared. And all of these are stored as an array of the coefficients. So this one would be 0, 3, and 1. And that just makes it easier, so I don't have to include the x cubed or x squared. So I just store the coefficients, because in synthetic division, that's really all that matters. So once you subtract these two polynomials, you want to remove the first term, which will always be 0, remove it from the array, and add the next term of the polynomial, which is 7x. So we would just add a 7, because that's the coefficient, and that would be the new array, just 3, 1, and 7. So then you repeat that process until you have the full quotient and the remainder. So this will be the full thing. This part would be printed as a quotient, and then this part would be printed as a remainder. Each term in this quotient would be A in each iteration, if that makes sense. It's difficult to explain, but if you understand synthetic division, this is just exactly what it does. All right, so let's test this code in Visual Studio just so you can visualize it better. That was a very brief summary of how this works, because there's a lot of functions and simplifying, but let's just run it with the same example. Our dividend, degree 4. That's how you input the polynomial. And then for the divisor, it's 2, 1, 0, and negative 1. And that's what we got. It prints them separately. And I added the parentheses just so it's easier to, see. And it's easier to read on a calculator too. So here's the actual code on a TI-84 graphing calculator. Have it named syndiv right here. Press run. Then it'll ask the degree of the dividend. That's 4, basically the same as in Visual Studio. That was 2. There we go. And then the advisor degree was 2, 1, 0, and -1. And you get the same answer. And it's formatted similarly to how it was in Visual Studio. It's just easy to visualize. Let's try another example. This one will be a little more complicated because it has fractions. The degree is 5. And that's the answer there. You can see the quotient and the remainder. This term actually has a fraction as the coefficient. I did it that way instead of decimal because I found that if you keep it as a decimal, it can be repeating and it's just hard to, round. So it's just much easier to have it as a fraction.